Hello students, today I am going to present my second video lecture on function. I'll discuss the definition of function, types of function and its related question. You can see in the screen that function is let x and y be two non-empty set. A function f from x to y is defined by f such that x to y, where each element in capital X is associated with unique element in capital Y. Okay? Let us take one example. Let x be a set having element 1, 2, 3 and y be a set of element pq. Now their Cartesian product is 1p, 1q, 2p, 2q, 3p, 3q. Now one function is taken whose elements are 1p, 2p, 3q. Now why f is a function? Because in f each element in domain have their unique images, and the domain of f will be the element of x 1, 2, 3, codomain of f will be the element of y, pq, images of 1 is p, 2 is p and image of 3 is q. So these are the definition of functions and the domain, codomain and images of function. I hope all of you understood. Now next I discuss the types of function. The first type of function is 1-1 function. A function f x to y is said to be 1-1 if images of distinct element of x are distinct element of y. That is, every element in domain x must have their unique image in capital Y in codomain. Now there is a rule of writing 1-1 function. When f of x1 equal to f of x2, then x1 must be equal to x2. You can see the mapping of 1-1. Every element of x, the domain, have their distinct images. Images are not same of two elements in domain. Here the elements in x having their images are in y, all the images are distinct. But here images of x, the elements 3 and 4 having same image c. So this will not follow the rule of 1-1 function. So this is not 1-1 function. These two are 1-1 function. This is not 1-1 non-injective function. Next type of function is onto function. A function f x to y is said to be onto function when every element in y must be the image of some of the element of x. That is, for every y belongs to y, there exists an element x in x such that f of x equal to y. You can see one example, f r to r defined by fx equal to x for all x belongs to r. You can see the mapping on the screen. First one, the elements in y, the elements of codomain d, b, c. All the elements are the images of some of the elements in x. Here all the elements in codomain are the images of some of the elements in x. Here all the elements in codomain are not the images. A is left. A is not the image of any of the element in x. So this is not onto. These two are onto functions. Next type of function is bijective function. It is a function when a function follow both 1-1 and onto criteria. Here you can see in this mapping that in x all the elements in x have their distinct images. So it is 1-1 and all the elements in codomain must codomain are the images of some of the elements in x. So it follow the rule of onto function. So it is both 1-1 and onto, and such type of function is called bijective function. Next type of function is many-one function. A function f x to y is said to be many one function if at least one element in y is the image of more than one element in x. That is, you can see in the mapping, C is the image of two element in x. Okay, image of 3 is C and image of 4 is C. This type of mapping is called many one mapping. Here also C is the images of 3 and 4. This is called many one mapping. Next is into function. A function f x to y is said to be into function if there exists at least one element in y which is not an image of any element in x. Here you can see the mapping. C is not the images of any of the element in x. C is left. So this is into mapping. Here also A is an element which is not an image of any of the element in x. So this is into function or into mapping. I hope all of you understood that the definition of function and its various types. Next, to go through one question based on this concept. You can see in the screen, the question is, check the injectivity and surjectivity of the following function. The function is f z to z, that is integer to integer, given by fx equal to x cube. Okay, first we prove whether the function is one or injective. Okay, the given function is f such that z to z fx equal to x cube. Let us take two elements in domain x1 and x2 belongs to z, and let us say that f of x1 equal to f of x2. Now since fx equal to x cube, so you can write f of x1 equal to x1 cube and f of x2 equal to x2 cube, and after simplifying we got x1 equal to x2. Hence we got f of x1 equal to f of x2, which implies that x1 equal to x2, which follow the rule of 1 function. Hence the function is injective function or 1 function. Next we are going to show whether it is onto or not. Let us take one element in codomain. 7 is an element in codomain, and we are going to prove whether this 7 is an image of any of the element of x or in domain or not. We are going to check. Now when x cube equal to 7, there exists no element in x for which x cube equal to 7, because 7 is not a perfect cube number. So since domain is an integer, so there will be no number in domain for which x cube equal to 7. So it will not follow the rule of onto function. Hence it is not onto function, it is not surjective function. We are going to show another question. You can see in the screen. Let us take two set A r minus 3 and set B r minus 1, and consider a function f a to b in such that the definition of function is x minus 2 by x minus 3, and we are going to prove whether f is 1 or and onto or not. First we'll check whether it is 1 or not. The given function is fx equal to x minus 2 by x minus 3. Let us take two elements in domain x1 and x2, and given, let us say f of x1 equal to f of x2. Since fx equal to x minus 2 by x minus 3, so you can write x1 minus 2 by x1 minus 3, and here x2 minus 2 by x2 minus 3. Now after cross multiplication and simplifying this, we got x1 equal to x2. Hence we got f of x1 equal to f of x2, which implies that x1 equal to x2, which follow the rule of 1 function. Hence the given function is injective function or 1 function. Next we are going to check whether it is onto function or not. Let us take one element in codomain, which is r. Sorry, y belongs to r. So y is an element in codomain. Now we are going to check whether y is an image of any of the element in domain or not. So this is the value of fx given. So x minus 2 by x minus 3 equal to y. After cross multiplication and simplification, we got the value of x equal to 2 minus 3y by 1 minus y, such that y not equal to 1. And this is the value of x that is in domain. And we are going to find the image of this point. which is fx. Fx equal to x minus 2 by x minus 3. Putting the value of x over there, 2 minus 3y by 1 minus y minus 2, 2 minus 3y by 1 minus y minus 3, and after simplification we got its value is y. So we are getting that y is an image of this point. Hence it follows the rule of onto function. Hence we can say that for every y belongs to y, there exists an element x in capital X such that fx equal to y. Hence the function is onto function. So we got the given function is 1 function and onto function. So we can say that the given function is bijective. So I hope students you understood the concept of function, types of function, and the question we have discussed. Lastly, I give you some assignment. You please go through it and try to do yourself. If you guys any question, any queries, you can contact me and I will help you out. Thank you very much.